Hey guys, so this is going to be on capturing clash data from Navisworks using Dynamo and a little bit of Python just to visualize some of the data. So to show you the workflow, we'll have a Navisworks NWF. Now that NWF is going to be made up of NWCs that we're dumping out of Revit or even Revit and AutoCAD and some other files. That all depends on what you're working with, but generally, that's made up of NWC files that you'll be clashing with. We'll read that info, so the clashes that we make, we'll read the info, just the total count in this example, but hopefully I can build something that can individually look at the clashes, and then that way we can report discipline-specific clash numbers, and then get those, for an entire company, which is really cool because then we can start finding correlations in like RFIs, reduced RFIs, reduced change orders, and so on. Now, this is oriented towards the design realm. A huge thing for me for leveraging, Clash in a design firm is to lower the barrier to entry into the tool, but also, reduce any redundancy in it at all. Because my experience was first using Clash was a very tedious and inefficient way, and to come into this and and try to apply, because I got the opportunity to apply Navisworks to a company, so I wanted to come in and apply a totally automated process for the most part. Where we couldn't do it with one tool, we would try to substitute with another tool. So what we could do in Dynamo, if we couldn't do it there, then we would try Python. If we couldn't use a tool like Clarity, which is a really great tool that we use, if we couldn't do it there, we would try Dynamo or Python, which is really nice because that raises the ROI, and then with the data tracking from this, we can truly show the value behind the tool, get more buy-in, and say this tool is valuable. And with our efforts of automating the entire process, you have an even higher ROI and less manual processes that you have to do in a project. So to kind of read this rest of this workflow, and we start with the Navisworks NWF, read the info with Dynamo, update the Excel file, which is just a database specific to that project, and then we read the data with Python. The idea, ultimately, for me, is to take the Python script, be able to read every single project's individual data, and then pull that into like an ultimate database that we can visualize and start finding correlations in different things. So before I get into this, it's not too difficult to do at all. It's actually really easy. You just have to have the tools in place. I'm going to share everything, so you can actually click on the OneDrive link, find the folder, and then just grab the Dynamo script, and you can find the sample Excel file, and then the Python notebook that I'm using. You can grab all that and use it however way you want. So a bit on the Dynamo portion of it. So it's Dynamo 2.0.3. Now you can try to apply this in different ones, but this is what I'm using currently. Bumblebee is one of the packages, and Dynaworks 19. Now Dynaworks is specific to versions, so keep that in mind, but Dynaworks 19 is what I'm using for this. All the things or the Revit Navisworks that I'm using is in 2019. And you can see over here in the install packages what versions of Dynaworks and what versions of Bumblebee I'm using. Now in the script, when you get it, it'll have them highlighted so you understand. If you do get any errors, definitely reach out and I'll try to help out. So the Python bit. Now, if you're totally new to this, so it's not a big deal. It's really easy, and the whole idea behind these notebooks and kind of what I'll show you is just to visualize and break down the code and visualize the output of some of the code, and it's just a really nice way to kind of see what's going on. Now, the way that I use it, and what's nice with this is you can avoid like admin permission stuff, is to go out to the Anaconda distribution site, and then you can download the Windows version. I would imagine you're using Windows if you're using Revit, but you do have the option for Mac and Linux. So, but go out there, download. I would recommend, especially if you're new, Python 3.7, so the latest one. Definitely don't go back a version. Install that, and you should have all the packages, but I did find that Plotly for some reason wasn't installed on my computer. But you can put this bit of code in there, which will pip install it, and then you'll have Plotly, and you can run import plotly.express. You can run that with no issues, and you could essentially run everything that I give you without having to really do anything. And then down here, we also use pandas in it as well. And then down here is the clash test. So the Excel file, we're reading that in Python, but I do give you a sample of it just to, so that you can see the data itself. Now, I created a sample clash test because I don't have any data inputs yet from a bunch of different projects. Now, I randomized those inputs, so they are kind of erratic, and you'll see it in a minute, but it does give you an idea of what you can pull out of Navisworks. So here is the example plot from Plotly. So in Python, we use Plotly to plot the data that we're pulling from Excel. And you can see it's really erratic. It doesn't really make sense. This probably wouldn't be the case for a project, but you can see that we can get that information out of there. So we look at a project and we can see from the data that it starts to the data that ends how the clashes are resolving. And we could also start to look at long-term, like we could estimate how clashes are going to get resolved and tell a client, okay, we're going to get it down to this number, and we're going to be pretty close to being pretty correct on that. By this time, we'll get it down to this number. And we can start finding correlations, too, as, when we start accumulating a larger data set, that from multiple projects, from multiple sectors, start to see that when we reduce clash or start to apply that workflow of resolving clashes on a project, that we do get reduced RFIs or reduced change orders or reduced things that ultimately cause the client more money, cause more time for the project team. And then we can show that to project team members. We can show that to clients and say, hey, we have this process in place that shows us that when we apply and use this technology, it ultimately saves you money on a project. It's all in concept right now, but it makes a lot of sense. If you can track it, then you can, start to iterate and improve. And that's the whole premise of this. So I'm going to close this. Just keep in mind that all you need is Dynamo 2.0. Just come back to this and you can check it out. In the location where you'll find everything, you'll also find this PowerPoint, and you can kind of go through here and just verify that you have the correct setup and whatnot. So I'll minimize this and show you the script itself. So starting off, we just browse out to the NWF. That's what we're reading. It's set to false so that it doesn't open in the background. It just keeps it closed. This opens it. Then we run all the tests. Now I think we can run individual tests, but I haven't tried this out yet. So I can start pulling those data or that data out. Then we get the clash test, and then we get all clash results. And since I only care about the total count, then I had to do a list flatten and just do a list count, and then whatever that number is. Now this code block is representing that number currently, so that when I run this, it doesn't get all crazy. Actually, I did that so that when I was testing it, everything worked. But in this example, so it doesn't get crazy, it doesn't run it and gets stuck. The idea behind this too is that you have it automated on some system that runs Dynamo scripts for you for specific projects. We use Clarity, but I'm sure there's a number of other tools out there as well that can run this for you so that you don't have to manually track this information. That's the whole idea. Now this bit here, so we do a list create just so that we can get the code block, or actually get the list count, or the total clash count, and then the date time when we got that information. And then we do some stuff there just to get that information together correctly. But this is kind of the annoying part. Maybe some of the more Dynamo experts can help me out. But I wanted to append the new information to an existing Excel document, not overwrite it in any way. Append it to a new line. The only way that I found that I could do that was if I originally read that information. So I open the Excel file here, I read it, I pull the information out. Then you can see here what we do is we read the information. I'm going to run this. Well, it looks like I can't, but we can read the information here from this, and then we just join this on as a new line to the existing Excel document. Now we have the updated, essentially the Excel document with the new line of data right here in list join. Then what we do is just remove all the nulls that it creates, and then I remove all the empties, and then I just dump into this Archilab. So this is the data input, so the sheet name origin. It's essentially what it's doing is it's writing a new Excel file every time it runs, which is kind of interesting, other than just appending the new information to a new line. So again, what we do is we read the existing one, so that could have like 20 inputs or up, to whatever input number that you have. So 20 inputs. When it hits here, it now has 21 inputs. It would be the 20 existing ones and the new input, so the new data input out on the new line. Then we do some cleanup. We come here. I do a pass-through node just to say, hey, wait up for this bit, or before you pass this bit, let all this run through. And then when it hits here, then pass the file path to this final node, write Excel, which will run it, and then write that data to an Excel file. So now you're going to have the existing data and then the new data input to your Excel document. And then when you restart it, it grabs those now 21 inputs and then adds the 22nd input, and does that every time you run it for that specific project. The idea too is through some automation that you'll repath these automatically based to a project, by replacing the string, so if you have something as simple as naming your Navis models, project number, then some default name, then you can replace that string value with a Revit project number. You can read that information, automatically replace it, then create a string, or combine the strings, and now you have a file path specific to that NWF, which is really cool for every project, and you don't have to set it up. Same with the Excel files as well. So I'm not going to run this because I'm afraid that it'll get messed up. And then right now it's saying it's not available, but I'm going to let it just sit here and show you the output of the Excel file. So I'm going to open up Excel, and then we can get an idea. So here there's a table. It says clash and date. So this is the total clash. So we have 1,000. This a total. It's totally erratic. But this essentially would be the total clash of this date over here, which is November 8th, November 9th, 10th, and so on. And that's all the data that we're essentially reading. Now this would live with a project folder specific to that project, and you would only be getting information for that project. Leveraging Python, you would reach in and then grab every single project's database and then pull that into a collective database that you would then use for visuals, or tie that into a Power BI dashboard or a SQL server or something to store that information, so you could start using it to make decisions and whatnot. Now to jump into the Python bit, if you're totally new to the Anaconda notebook or Jupyter notebooks and stuff like that, to start it off, you would just come here and type in Anaconda prompt, and then when that opens up, all you would type in is Jupyter space notebook, and you would spell Jupyter in this way, so Jupyter, then space notebook, no capitalized letters. When you type that in, it'll open up and it'll allow you to browse out to a notebook. If you pull down my notebook, then you would just browse out to that one and open it up, and then you'll find this. Now to just real briefly tell you what this is, there is you can break this out into different things, one of them being Markdown and the other being the code. Now Markdown is used for like text and stuff. You'll see it in like blogs and different things like that. It's just a nice way to convey the information, make it a little bit cleaner or a little bit more apparent to what you're talking about. You can use that instead of like adding a line, or like coming down here and adding a comment line like that in code that you may have seen. Instead of doing that, up here I just use Markdown to say importing the Python libraries, reading the Excel clash test, which is really cool. But up here, there's just packages, so I put just miscellaneous information that I find. I call this packages. I may change that, but essentially I have some of the common things that I use. Up here is a bit on code, Markdown links, in case you want to learn a little bit more. Python links. For this one, I should have maybe updated it, and maybe I will later, but I would put just relevant Python links to whatever this script was. General resources, YouTube vids, common resources, Stack Overflow, Python 3 documentation, 2 really great resources to check out. So if we go down here, we can see that we're importing pandas, which I mentioned before. We are not importing NumPy, so I can remove that. Importing plotly.express, and that's it for the packages that we're using. Now all you would have to do is when you go into a cell, you would just press shift and then enter, and that would run it. Now this cell's already been ran. It's reading the most updated information, so I'm not going to run it again, especially in case we run into an error for whatever reason. But when you open it, you would just run it. Just make sure, because you can change the directory, but if your Excel file that you'll find when you find all the information for this video, when you have that Excel file, just make it live wherever the notebook lives, and you won't have any problem having it path correctly. Because you can see here, I'm not specifying a path in any way. I'm just saying clash test underscore 2019 dot, which is the Excel file's name, and you won't have any issues as long as it lives in the same location as the notebook. If not, you'll have to change the directory. So this is the actual information now. So you can see pandas, and that's what that PD means. We can see up here, import pandas as PD. So pd.read Excel. So we read that Excel, we now have a database of that information. Down here, I just make a data frame, so pandas data frame. And then down here, I can get some info on that data frame. So dataframe.info, get some stuff, describe it, get some more information. And then down here is the bit on actually from Plotly, which is not running because we haven't imported the libraries yet. So what I'll do is press shift and enter, import those. We'll come back down here and try to run it even though it's still running, see if it does. So what we'll do is just run all this and hopefully it works. So we'll run that. We can see the pd.read Excel worked. It read that information. Down here we'll create the database, so I'll do a shift and then enter for that one. For these, we can ignore the information is relevant and up to date. And then down here, what we'll do is we'll run that. This will run for a second, and then we'll see the plot. This is a interactive plot. You can kind of hover and highlight different things, and you can also zoom into the plot itself. But you can see here we have the clash over here to the left, so 500 to 4,000, and then down here is some of the dates, and then through here we can get more information. But you can see it's really cool. I mean, we can in a pretty much, well, depending on the tools that you have, a all the way automated process of retrieving that clash data, and then you can visualize that data in here. Now the idea is to then tie this to other elements, like how this affects your projects. Are you saving money when you use this tool, so that you can iterate and improve the process. But this is a great starting point, I think. So hopefully this made sense to you. If you have any trouble with the tools and what you need to get this working, let me know. It is really easy to do. It's not too difficult. But if you do run into any issues, it's probably going to be because of version issues, stuff like that, what version of Dynamo, or for whatever reason you're on Python 2, which I can't say if it would mess it up or not. I'm not sure. I'm sure Pandas has made a lot of improvements to their library since 2, so you may find some issues there. So, but do let me know. Reach out if you have any issues messing with this process or trying to recreate what I've done here, and I'll try to help out the best that I can. For a lot of this automation and for automating the Dynamo scripts and creating different things, I am also using Clarity, which is a really nice tool, so worth checking out. But you can, and I'll have to look into it, but there may be ways to recreate that without having to go out and buy that tool, because it is very expensive. So I'll be working on some Python things to see what else I can do with it. I know I'll be extending this process, but I'll look into those things that I'm using one tool over. I'll try to recreate in Python so that I can share that with you guys. Thanks a lot for watching. I really hope this helped you guys out. Feel free to reach out anytime. Thanks.